Hello everyone, let us look into this question. In the given below figure, from an external point P, a tangent PT and a line segment PAB is drawn to a circle with center O. See here, PAB. So this PAB acts like a secant and PT becomes a tangent. ON is perpendicular on the chord AB. AB is the chord and ON is the perpendicular one. So we have to prove these three conditions. PA into PB is equal to PN square minus AN square. PN square minus AN square is equal to OP square minus OT square. And the third one is PA into PB equal to PT square. These three conditions we have to prove it. Now let us start the solution for this. Okay, the first one. PA into PB is equal to PN square minus AN square. We will try to prove this one right now. So first, if you check this correctly here, according to the figure, if you see, if I want to get this PA, I can get this PA from this complete part. How I can get it? PA is equal to PN minus AN. From this complete PN, if I remove this AN, I will get PA, right? So I can write, so when I am solving the first case, for this I can write that PA is equal to, I can write it as PN minus AN. Okay, PN minus AN. You got it. Now similarly, PB. If you check this PB, to get this complete PB, here, this complete PB I want. To get this PB, I can write this as PN plus BN. Right? So PB is equal to PN plus BN. Right. Now it is clearly told that ON is perpendicular to AB. Right. So since ON is perpendicular to AB, it bisects AB. Right. So now you can write one word that BN is equal to AN. On what basis? Since ON is perpendicular to AB. Right. So BN is equal to AN. You got it up to here. So in the place of this BN, I can write AN again. Okay. So now the first case is PA into PB, that I have to take it on the LHS. Now when you start the LHS here, PA into PB is equal to, what is PA you got here? PN minus AN. This is PN minus AN into PB is PN plus BN. This BN equal to N will substitute in the next step. So you can first will write this as PN plus BN. Okay. Now here we already got this as BN is equal to AN, right? According to these concepts, is ON is perpendicular onto AB. So here in the place of this BN, I can write AN again. So what I will get this part as PN minus AN into PN plus AN. So A minus B into A plus B. This becomes PN square minus AN square. So therefore PA into PB is equal to PN square minus AN square. This is what we have to prove it. Right? So first condition we got it. Now come to the second one. What I have to get the second one? PN square minus AN square is equal to OP square minus OT square. Now for this, first I have to take LHS, that is PN square, and I have to take AN square. Now check it out which triangles are related with this. For getting PN, I can take the triangle as ONP, right? And for AN, I can take the triangle as ONA, right? So I'll consider these two triangles. From triangle ONP, first case, ONP, since ON is perpendicular, so of course perpendicular to AB in the sense here the angle will be 90 degrees. So according to the Pythagoras theorem, what can write? OP square is equal to ON square plus PN square, right? So by Pythagoras theorem, OP square is equal to ON square plus PN square. ON square plus PN square. So from here Pn square is equal to OP square minus ON square. Right? Let us suppose name this as equation 1. Similarly, we will take out one more triangle. See, we want AN here. To get this AN, the triangle which is related to that is ONA. So from triangle ONA, right? So OA square is equal to ON square plus AN square. ON square plus AN square. So therefore AN square becomes equal to OA square minus ON square. Let us name this as equation 2. Now, if you just check it out, actually what we have to prove it. See, Pn square minus An square is the LHS, right? I got Pn square, I got An square. Let us subtract these two equations, right? So this means I will write this as equation 1 minus equation 2. So LHS gets subtracted, RHS gets subtracted. So what can I write here? Pn square minus An square here. So Pn square minus An square is equal to OP square minus ON square is this here. That means OP square minus ON square we have in this minus. What is the RHS of the second equation? OA square minus ON square. OA square minus ON square. When you open the brackets, this becomes OP square minus ON square minus OA square plus ON square. This is OP square minus OA square, right? But if you see what we have to prove, actually it is OP square minus OT square. So if you join this OT and OA, both becomes radius of the circle, right? Right, OT and OA becomes radius of the circle. So here I can write one word that since OA is equal to OT, that is radius of the circle. So now according to this concept, what I can write here in the place of this, so according to this criteria, if you have this as OA is equal to OT, so the meaning of this is in the place of this OA I can write here as OT, right? So what I will get? OP square minus OT square. So finally Pn square minus An square is equal to, I got this as OP square minus OT square. This is what we have to prove, the second condition. Now let us go to the third condition. First let us see what I have to prove actually. I have to prove it as PA into PB is equal to PT square, right? So to prove this, right, from first condition actually what we got? From first condition we got that PA into PB is equal to Pn square minus An square. From first condition PA into PB is equal to Pn square minus An square, we got it. From second condition what we got? From second condition we got it as Pn square minus An square is equal to OP square minus OT square. So from 1 and 2, what can I write? Since PA into PB is equal to Pn square minus An square I have here, and from the second equation Pn square minus An square is equal to OP square minus OT square. So from 1 and 2, what can I write? Therefore from 1 and 2 I can write it as, from 1 and 2 I can write here as PA into PB is equal to OP square minus OT square, right? So I can write here as PA into PB is equal to OP square minus OT square, right? But what we have to prove? I want to get PT square. I have to get PT square here. So if I join this OT, here, then OTP forms a triangle, that too right angle triangle, because the tangent and the radius where they meet, the angle will be 90 degrees, right? So from triangle OTP, since it is a right angle triangle, what can I write? OP square is equal to OT square plus PT square, right? I can write here as OP square is equal to OT square plus PT square. So from this, therefore PT square is equal to what I will get? OP square minus OT square. Right. So that means in the place of this OP square minus OT square, I can write PT square here. Right. So therefore, PA into PB is equal to, in the place of this OP square minus OT square, what can I write? PT square. Right. So we already proved the third condition also. So I think we have completed all the three conditions. Right. So this is the final answer. So we will meet with the next question next time. Thank you.